I'm glad you joined me for this video. We're going to be talking about graphing quadratic functions. There are several things I'm going to talk about and include in my graph. You may or may not have to talk about all of this information or include all of this information on all of the problems. But I wanted to go ahead and give you the information, and then you can use the parts that you need. So we're going to graph. We're going to find the axis of symmetry, and we're going to include it on our graph. We're going to find and label the vertex along with at least two other points, and we're going to decide if the graph has a maximum or minimum, and we're going to give that value. The maximum or minimum values will probably become important later if you're doing application problems about the quadratic functions. So let's get started. So to graph, we want to kind of first know what to expect. We can use end behavior or the leading coefficient and the leading term to decide if the graph is going to open up or down. So since this is a square, a quadratic, we know that it's going to be a parabola, meaning it's going to be shaped like a U. So the graph is going to look like this or something like this, some kind of a U shape. It's going up like the first graph if it's a positive x squared. So if the coefficient of the x squared is positive, it's going to be opening up. On the other hand, if the coefficient of the x squared term is negative, so there's a negative in front of that, it's going to be going down. In the case where it's positive, notice that you have a bottom. That means you're going to have a minimum in that instance. If you have a negative in front of the x squared, notice that you have a very top. That is going to be a maximum. So anytime you have a positive x squared, your parabola will be going up, opening up, and it will have a minimum. Anytime you have a negative x squared, your parabola will be opening down, and you'll have a maximum. So keep that in mind as you start. So let's look at our example. We have a positive 2x squared. So because this 2 is positive, we know that we're going to have a parabola that opens up, and it's going to have a minimum value. Oh man, I can't spell minimum. Let's try again. Minimum. The minimum and the maximum both appear at the vertex. So when you find your vertex, you're also finding your min or max, depending on the situation. Let's figure out now how to find the vertex. So to find the vertex, you can use the formula. So the x value of the vertex can be found using the formula negative b over 2a. B is always in front of the x, and a is always in front of the x squared. So in our example, a is 2, and b is negative 8. So I will have a negative 8, so that's going to be a positive 8, over 2 times a, which is 2. So that's 8 divided by 4, which is 2. So the x value of the vertex is 2. Remember that the vertex is an ordered pair, so it has both an x and a y value. So we found the x value. To find the y value, you simply plug the x value into your function. So since x was 2, we're going to find the function value of f at 2. So we're going to plug 2 in everywhere we have an x. So we're going to get 2 squared is 4 times 2 is 8 minus 16 plus 3. So that's going to be a negative 5. So we have an x value, we have a y value, so we can put those together as the vertex in an ordered pair. So the vertex is 2, negative 5. So there's part of what we were supposed to find. Find and label the vertex. So 2, -5 is our vertex. Since we know that it opens up, we know that that should be the very bottom, bottom that it goes. So in other words, the minimum. So all the other points that we find should be above that point. So we want to find at least 2 other points, and we can do that by just choosing points. I like to choose x values around the vertex. So since the vertex is at 2 on the x-axis, I would pick 1 and 3 to plug in and see what I get for y values. So I'm going to choose x equals 1, and I'm going to plug it in and see what I get. So 2 times 1 squared minus 8 times 1 plus 3. That's going to give me my y value. So that's going to be 2 minus 8 plus 3, and I'll see that I get -3. So 1, -3 is another point on my graph. So I'm going to go and plug that 1, -3. I'm going to plot that on my graph. And now I said I'm going to choose 3. So I just choose an x on each side of the vertex. If I'm choosing one that's equally far apart, like I'm choosing one to the left and one to the right of the vertex, you should notice that there are mirror images. So we have x equals 3. I'm going to have y equals 2 times 3 squared minus 8 times 3 plus 3. So 3 squared is 9, times 2 is 18, minus 8 times 3 is 24, plus 3. You will see that I will get -6 plus 3 is -3. So 3, -3 is another point on my graph. So 3, -3. So now once I have 3 points, at least 3 points, I can connect those dots. And if I wanted to find other points, I could. If I would have chosen 0 and 4 instead of 1 and 3, that would be fine. If I choose 0, I would get 3. And if I chose 4, I would get 3. So those are points on the graph as well. Once you have at least 3 points, you have an idea what your graph looks like. You know it should be a U or a parabola because it's a quadratic. You can connect those points and then put arrows on the end to show that they're going up forever. So that's a sketch of the graph. So let's see what I've done so far. Graph, I did that. Find the axis of symmetry and include it on your graph. I have not done that yet. Find and label the vertex along with 2 other points. All right, I've done that. Decide if the graph has a minimum or maximum and state the value. Okay, so I've already kind of talked about that it has a minimum, but let's look at that. So I'm going to erase this work so far. If you need to pause now and write it down, go ahead. Okay, so let's kind of summarize what we've got so far. So the vertex, when you find it, you can get a lot of good information from it. So the vertex we have as 2, -5. Because it's opening up, it has a minimum. So we're going to go ahead and list that. The minimum or the maximum value, they're looking for the y value. So the minimum value is -5. The minimum and maximum values always correspond to the y value of the vertex. So the y value of the vertex is going to correspond with the minimum or maximum value. It always works that way. So that's something to keep in mind. So decide if the graph has a max or min and to state the value. We've done that now. Last thing is the axis of symmetry. If you look at your graph, you should see that it looks similar, like I could fold it in half. And in fact, you could fold it in half along the line that goes through, the vertical line that goes through the vertex. So your vertex is kind of like the middle of the graph. And then each side looks exactly the same. That's why it's called the axis of symmetry, because it's symmetric about that line. The axis of symmetry, since it's a vertical line, is always an equation. X equals wherever it passes through the x-axis. So in this case, it's x equals 2. So the axis of symmetry should always be written as an equation, and it's always x equals, and again, it's where it crosses the x-axis, so x equals 2. Notice that this value is the same as the x value of the vertex. That's also always going to be the case. So once you have the vertex, you also have the minimum or maximum value, because it's the y value of the vertex, and you also have the axis of symmetry, because the axis of symmetry is the equation x equals the x value of the vertex. So I've now finished. I've included everything I needed to for this one, so I'm done. Let's look at one more example. So I want to include all of the same things here. First thing I like to do is just decide what my graph is going to look like. In other words, is it going to open up or down? Since it's a negative 3x squared, this negative in front is going to let me know that I'm going to have a graph that opens down. So the arrows are going to be pointing down. That means I'm going to have a maximum. So I'm going to keep that in mind as I work through this and make sure that when I pick points and am connecting my points, that my graph looks like what I expect. So first thing, find the vertex. So the x value of the vertex you can always find by using the formula negative b over 2a. Remember that b is the number in front of x, and a is the number in front of x squared. Notice that there is no x term. That means it's like I have 0x. So that means I'm going to have 0 for b. Well, 0 is 0 divided by anything is 0. So the x value of the vertex is 0. Now I'm going to find the y value of the vertex. So anytime the b is 0, if there's not an x term, your x value of the vertex is going to be 0. And now I'm going to plug that in. So negative 3 times 0 squared plus 4. Well, this is just going to be 0, so this is going to be 4. So I have an x value of 0, a y value of 4. So my vertex is going to be 0, 4. Now from that, you automatically know your minimum or maximum value. Since it's opening down, we're going to have a max. So maximum, and the maximum value is always the y value of the vertex. So I can say the maximum is 4. I also automatically know the axis of symmetry. Remember, the axis of symmetry is always an equation, x equals the x value of the vertex. So x equals 0 is the axis of symmetry. So now I can go ahead and graph all of this. So 0, 4 would be here. That's the vertex. The axis of symmetry, I can go ahead and do a dashed line. There's that. And now I need to pick some more points to graph. Remember that you can choose anything you want to plug in for x, but you really want to pick something that's relatively close to your vertex. So 1 and -1, 2 and -2, something like that would be a good choice. So I'm just going to go ahead and choose, let's say -1 for for x. So choose x, -1, and then I'm going to see what I get for y. So we'll have -3 times -1 squared plus 4. So -1 squared, we've got to do that first. That will give me a +1. Times a -3 would be -3 plus 4. So that would be 1. So -1, 1 is another point. So -1, 1 is another point on my graph. And then I chose 1, so I'm just hugging that x value of the vertex. Since it was 0, I'm picking -1 and 1. I'm going to have y equals -3 times 1 squared plus 4. 1 squared is 1 times -3 is -3, and -3 plus 4 is 1. So I'm going to have 1, 1 as another point. And you can see that those look about the same distance away. In fact, they are exactly the same distance away from the green, right? From the axis of symmetry, because it's symmetric about that line. And so now we can connect those to make our graph. We know it's going to be a kind of a U shape, a parabola, and that would be the sketch.